All right, good afternoon. Welcome back to Elements of Calculus 2. We are looking at our our problem inventory for test 2. This is problem number, I think this is 8. Let me double check here. This looks like, heck if I know. 7. Sorry about the wait on that one. I believe this is problem number 8. There it is. Problem number 8. Very good. All right. So this is a differential equation. It's a first order linear differential equation. It's linear because there aren't any y squareds or dy squareds or anything like that. So no logarithm of y's. Logarithm of x would be just fine. But where we talk about linear is it's linear with the y part of things. So all the variables that have a y in it, the only thing it can have is it has to be attached to a coefficient. Okay. The first thing you're going to look at for this is you're going to say we have to put it in the proper form. And the proper form is the dy by dx can have no coefficients. Okay, so we have to go ahead and divide everybody through by 1 over x to make sure there's no coefficients in order to set this thing up correctly. It can have coefficients later, but it can't have coefficients after the first move. So the first move is multiply the entire equation by 1 over x. So we have to end up with dy by dx minus 5 times y over x is equal to x squared over x. It's just going to be x. All right, so we have to go ahead and find an integration factor. So we're going to say rho, that's my integration factor. That's the symbol that they used for me. And this is going to be e to the integral of whatever happens to be next to the y. So we have a negative 5 over x here. Okay, that's what we have to integrate dx. So we'll go ahead and deal with that. So rho is still equal to e to the. Now we have to integrate negative 5 over x. So this is going to be negative 5 ln of x. Okay. Now I like to do it this way because there's a mistake that I watch even the people who take the differential equations class make this mistake. They say, oh, it must be negative 5 and we're done. I'm like, no, can't do that. Let's put it in a proper form. We're going to use a property of logarithms to say rho is equal to e to the ln of x to the negative 5. Now we can go ahead and evaluate e to the natural log of x to the negative 5. This is just equal to x to the negative 5. We're going to multiply through by x to the negative 5. So we're going to say x to the negative 5 dy by dx. Okay. Minus 5 is x to the negative 5. So it's really going to be y over x to the 6th power, isn't it? Because 5 plus 1 would be 6 equals, and we're just multiplying through by x to the negative 5, x to the negative 5 times x squared. That's going to be, or just times x rather, it's going to be x to the negative 4. Okay, we're just multiplying through by x to the negative 5 here. Now, the reason why we did this is because we have the whole point of integration factor is like we know that there's something going on here, but we're not sure what. But we're going to introduce this factor in order to make sure that we can integrate it. So what we're going to be integrating is going to be 5x to the negative 5. Okay, actually, it's going to be x to the negative 5 times y. That's what we're saying that this whole thing is going to be. Okay, that it's the product rule. Somebody performed the product rule on this particular idea here. So we could go ahead and verify this. So product rule says derivative of the first. So we have negative 5 x to the negative 6 times the second plus the first x to the negative 5 times dy. And I'm going to ask you, does this look anywhere similar to what we have right here? Like, well, we have an x to the negative 5 dy. Yeah, we sure do. And we have a negative 5 x to the negative 6 times y. We sure do. So this thing is the derivative of x to the negative 5 y, and we're saying that that's equal to x to the negative 4. All right, now, fundamental theorem of calculus says we're going to go ahead and we're going to integrate something we took a derivative of. We should get back the same thing. So this is going to be x to the negative 5 y equals, and we'll go ahead and integrate x to the negative 4. That's good. We're just going to add 1. This is going to be x to the negative 3, and we have 1 over 3 negative plus c. All right. Last thing we're going to do, because we want to get this in terms of just y, so I'm going to go ahead and multiply everybody by x to the 5th. That'll cancel out my x to the negative 5, so we're just going to say y equals. x to the 5 times x to the negative 3. This is going to be negative 1/3. Negative 3 plus 5 is 2, so we have negative 1/3 x squared plus c x to the 5th. All right, now we're almost done. We have an initial condition on this problem. Our initial condition says something clever like y of 2 is equal to 12. So that means when x is 2, this whole function is equal to 12. So we're just going to say this is 12 equals negative 1/3, and we're going to put in 2 squared here, plus c times 2 to the 5th power. So we're going to say this is 12 is equal to negative 1/3. I'll say negative 4/3 because 2 times 2 is 4. 4 times 1/3 is 4/3. Plus, and 2 to the 5th is 32. C. And we just have to go ahead and solve for this. So we're going to solve for C here. So we're just going to say, okay, we have 12 plus 4/3, right? We're just going to add that. And this is equal to 32C. All right, not too bad. We have to go ahead and get common denominators here. That's 3/3. So 3 times 12, that's going to be, I think we're going to get 36. Yeah, 36 over plus 4 all over 3 is equal to 32C. 36 plus 4, we're going to end up with a 40/3 equals 32C. Go ahead and divide both sides by 32, and we'll get C is equal to 40 divided by 3 times 32. I'm going to be lazy and do it this way. So we've got 3 times 32 here. Let's see here. We've got 3. Good Lord. There we go. 3 times 32. Would have been faster for me to do it in my head at this point. 96. So C is equal to 40/96. So my end solution here, the answer I'm going to box here is going to be y is equal to negative 1/3 x squared. All right. Uh, Plus, we're going to say 40 over, what was that? 96? 40/96 x to the 5th. And that's our values for this differential equation. That's our solution here. Okay, if you want to hide the negative sign, that's fine. Y is equal to 40/96 x to the 5th minus 1/3 x squared. Okay, and there we go. That's it as far as that goes. So these are really nice. I like these problems. The integration factors always make me feel kind of nice. Just be careful when you have your integration factor and there's negative signs in here, even if there's positive signs. Remember to undo and use rules of logarithms before you say e to the something logarithm to get your integration factor to multiply both sides by. Okay, so just be kind of careful when you're doing this intermediate step right here to make sure you're going to get the correct integration factor. Okay, so with that, I'm going to say thank you very much for watching. Good luck on the test, everybody, and I will see you in the next video. Goodbye.